R for relationship. Okay, it is important to know how the relationship between the values, okay, of the x-axis and the value of the y-axis. If there are no relationships, okay, the linear regression is not a good choice. Okay, it means that you should not select the linear regression, okay, for solving the problems. Okay, because linear regression, or it cannot be used to predict anything if there are no relationships. All right, so this is why we need to identify the R values. Okay, if we know the R values, the value of R, okay, we can make decision. Okay, we use linear regression to solve the problem, or we use some other techniques to solve the problems. So relationship, the coefficient of correlation, okay, we call it R. The R value range from -1 to 1, as you know, where 0 means no relationship. Okay, if 1, R is equal to 1, okay, very strong relationship, okay, positive relationship. If R is equal to -1, very strong, but very strong negative relationships. All right, and Python and SciPy module will compute this for you. Okay, all you have to do is fit it with the x and y values. Very easy. Okay, how well does my data fit in a linear regression? If you have a set of data, if you have a set of x and set of y, so very easy, okay, to check the coefficient of correlation R. So we can just put here x and y and then stat.lingress, all right, and you get the key elements of the linear regression models like slope, intercept, R, P, and standard error. So easy, you can just print R, coefficient of correlation, print slope, print intercept, y-intercept. So print R, okay, we focus more on R relationship, right? R is minus 0.7. What does it mean, minus 0.7? Maybe strong negative relationships. All right, strong negative relationship. If you look at this data set x and y, what happens if you compute it and R values is 0.4? This is positive, all right, positive, medium, just medium, positive relationship, right? Okay, one more time, okay, one more time. Okay, create the array x and y here. If you want to okay, you study, okay, you study about the relationships about between the two variable x and y. Okay, you know R values, you know slope, and you know y intercept. But actually you should get the linear regression equation at this point. And then you want to identify the linear regression line, you do the same thing. Okay, try to repeat it one more time. Okay, create the array, execute the method that return some key values of linear regression, like by calling, okay, stat.linRegress, linear regression, and you create a function. Okay, you create a function, and now you know the slope values here. You know the intercepts. Okay, intercept, and we're gonna use map my function in x. It means you are going to run each value of x array. We do the same thing. Okay, I give you this kind of problem to different example, okay, to let you have an experience with or familiar with Python programming, okay, especially in linear regression code. Yeah, and then you draw the scatter plot and draw the line, okay, it shows you the positive relationship, right? R is equal to 0.4, okay, something like this. Okay. Okay, this but actually, could you still remember this problem? This problem is a midterm exam question in midterm exam. All right. If you could still remember, okay, I give you the quiz test, all right, and midterm quiz test and midterm exam test, all right, and I asked you if the score x is equal to 28.5, okay, you can just predict, okay, the midterm score. Okay, in this case, very easy. The answer is 17.87. Okay, and the results minus 0.76 shows there's a relationship but not perfect, but it indicates that we would use linear regression, okay, in future prediction. So predict future values. We use the information we have gathered to predict future values. Okay, let us try to predict the speed of 10 years old car. We need the same function from the example above. Okay, the same thing. Okay, this is another case. Okay, the speed of 10 years old car, so x is equal to 10. Okay, the speed is approximate. Not approximate, predicted value is 85.759. So and then we talk about bad fit. Let us create an example where linear regression would not be the best method to predict future values. For example, this is x and y. Okay, we do the same thing. Okay, and when we plot the scatter diagram, okay, scatter plot, it's something like this. It's something like this. Okay, it's something like this. Okay, it's scatter. Okay, you see it's scatter. It's scatter. Okay, if you plot x and y like 89 and 21, okay, 43, 46, okay, we plot pairwise, okay, x and y into the two-dimensional space here. So, and we can observe that it scatter. So when we draw a linear regression line, so it shows like the line that runs in parallel with the horizontal axis or x-axis here. You see, if we compute R, you see, we compute R for this. Okay, we plot, we try to plot the line of regression first, and then we compute R, okay, to confirm what we have seen. Okay, and R, we get it 0.013. It shows almost like no relationships between the variable x and y. So the result, okay, 0.013 indicate a very bad relationships and tell us that this data set is not suitable for linear regression. And what happens if it is not suitable for linear regression? We have to find some other techniques, okay, in regression, like maybe polynomial regression or multiple regression. It depends on the cases. So, and next we are going to talk about polynomial regression. Okay, machine learning polynomial regression.